Welcome to Chemistry 101 at Goodwin College. Today we are doing Unit 5, Part 1, which is basically the first half of Chapter 5. So we're breaking Chapter 5, or Unit 5, into two sections, primarily because this is one of the more difficult sections in the class. So it might be a little bit easier if we went over it a little more slowly and basically broke it into two pieces. At this point, the next couple of slides are really a little bit of fluff. I probably, at some level, I shouldn't include them in the online lecture material. These are slides that I usually show to the on-ground students, but it might be helpful just in focusing your attention. So this is one of the slides that I show, and it basically tells the students, pay attention. This is going to be a little bit of a difficult lecture for at least some of you. The next slide is also a little bit of fluff, but I like the quote, and it's relevant to today's lecture. The quote is, in mathematics, you don't understand things, you just get used to them. And it doesn't really matter who said that. I like the quote. And the idea is that sometimes the topics can be a little bit more difficult to understand, and you might think that you will never be able to understand them. But eventually, after just sort of being exposed to them and being around the ideas for a while, sometimes you can just get used to them. And you wake up one day and suddenly you basically understand the concept, even though you don't really understand how it happened that you came to that understanding. So for some of you, I hope that that's true. If this is a difficult unit for you to get through, hopefully you will wake up in a month or so and suddenly understand what we're talking about. For others of you, this may be relatively easy. So if it is, you should sort of be happy with that fact. So that being said, let's go on to the beginning of Unit 5. However, before we get to the beginning of Unit 5, I actually think it would be useful to give a brief review of what we've done over the last few units, really. So the first part of the review actually deals with some of the stuff that we talked about in Unit 3. In particular, we're going to talk about the mass of an atom again, and I want you to be familiar with that. So this is sort of a similar table to the one that I showed you in Unit 3. Here I'm only talking about protons and neutrons, and basically what I want you to remember is that protons and neutrons have roughly the same mass. And if you want to think about mass as weight, you can think about it as weight. So you can say that protons and neutrons have almost identical weights. They don't weigh very much, but they do weigh something. So a proton weighs about 1 Dalton, and a neutron weighs about the same thing. It weighs about 1 Dalton. So then I went through this exercise where I showed you different types of atoms. So here's an atom over here, and my cartoon representation of a proton is going to be a red circle. So this atom over here has one red circle, meaning it has one proton. And then I asked, what's its mass? What's the mass of this particular atom over here? And you basically just count up the protons and neutrons, and you say, look, this atom over here weighs 1 Dalton. And if I asked you what kind of atom it is, you would say, well, it has one proton. The atom that has one proton is hydrogen. So again, this should just be a review. I showed this type of atom to you as well, and I might have asked you, what kind of atom is it? Well, it has 2 protons, so the atom that has 2 protons is helium. And then I could ask you, what's the mass of this particular atom? Well, each proton weighs 1 Dalton, and that's all there is in this atom. So the mass of this helium atom is 2 Daltons. And then, again, I asked you a slightly more complicated question, probably what type of atom is this atom over here? It has 2 protons, 2 red circles, and 2 neutrons, 2 gray ones. And then basically, what type of atom is it? Well, since it has 2 protons, it's also a helium atom. But then, if I asked you what's the mass of this helium atom down here, you basically have to realize that protons each weigh 1 Dalton, neutrons also weigh 1 Dalton. And this atom over here has 2 protons and 2 neutrons, so its mass is 4 Daltons. So even though this atom here on the bottom and this atom in the middle are both helium atoms. The one in the middle has a mass of 2 daltons, and the one on the bottom has a mass of 4 daltons. And then the other punchline really was that as far as we're concerned, and as far as most people are concerned, the electrons don't have enough mass to count in these calculations. They don't weigh enough to count. So that's the first part of the review. I want you to realize that you can basically determine the mass of different atoms by figuring out how many protons and how many neutrons they have. The next part of the review deals with something else that we talked about in Unit 3 or Chapter 3. And just as a reminder, atomic number is the number of protons that an atom has. And I reminded you about this in Unit 3, and then I basically asked you a series of questions. I said, first of all, what kind of atom is this? And it should ring a bell from the previous slide. This atom has 1 proton. You look up which atom has 1 proton in the periodic table, and it's hydrogen. And then I asked a series of other questions about different types of atoms. Here's a different atom. It has 1 proton and 1 neutron. And I said, what kind of atom is this one? And hopefully you remember that it also just has 1 proton, and that basically tells you what type of atom it is. So this is also a hydrogen atom. It has a different mass than the hydrogen atom on the left. This atom over here has twice the mass. It has a mass of 2 daltons, and this atom over here, this hydrogen on the left, has a mass of 1 dalton. Then I showed you a third atom, and I said, what type of atom is that one? And hopefully you realize now that this is also a hydrogen atom. It has 1 proton, which makes it a hydrogen. It also happens to have 2 neutrons as well, which means that this hydrogen atom on the right is 3 times as heavy as this hydrogen atom on the left. So this guy over here weighs 3 daltons, or 3 atomic mass units. And then basically I introduced the idea that, just to point out to you, that you could call it heavy hydrogen if you wanted to, and you could call this atom over here heavier hydrogen. And then I introduced the term isotope. So these are all isotopes of hydrogen atoms, and isotope is basically just fancy talk for a version of an element that's either heavier or lighter than other versions of the same element. So this atom here is an isotope of hydrogen because it's lighter than these other two. And this atom in the middle is an isotope of hydrogen because it's heavier than this version and it's lighter than the version on the right. And the same thing holds true for this version of hydrogen over here on the right. It's heavier than the other two. They're all isotopes of hydrogen. And again, just to emphasize, all isotope means is some version of an element that's heavier or lighter than other versions. So again, this should be review, but it'll come up in the rest of the unit, so I want you to keep it in mind. The other thing that I want you to be able to do is to be able to confidently read a relatively detailed periodic table. So this, what I'm showing you on this slide, is only a piece of the periodic table, but it's showing a lot of the atoms that we will talk about in this course, so it's a relevant piece of the periodic table. And I just want you to be able to read what's inside the different boxes. So on this box over to the left, you should be able to realize that the capital H here is the symbol for hydrogen, that the number 1 here is basically telling you what the atomic number for hydrogen is, and the atomic number means how many protons each hydrogen atom has. And then this other number, 1.0079, will become important in this unit, but you should remember from, I believe, Unit 3, that 1.0079 is telling you the average atomic mass of a hydrogen atom. So what that means is that most of the hydrogen atoms have a mass of 1 dalton, but there are some isotopes of hydrogen that are a little bit heavier than 1, and because of that they bring the average atomic mass of hydrogen up a little bit above 1, which is why this number isn't exactly 1. It's a little bit bigger than 1. And you can do this for any of the atoms in the periodic table. You can do it for helium. You can say, oh, look, helium, its symbol is capital H, lowercase e. All helium atoms have 2 protons, and the average atomic mass for a helium atom is just over 4 daltons, or just over 4 atomic mass units. So I want you to be able to look at the periodic table and tell me that type of information for any of the 118 different elements. This next part isn't exactly a review, but it should be relatively easy for you to understand. So if I wanted to talk about an oxygen atom, and you looked it up on the periodic table, you could basically look at the information for oxygen, and you could say, look, oxygen has an average atomic mass of about 16 AMU. That's what this little squiggly line means. That means about. And so I want to keep it at 16, even though the real number is about 15.999. I want to keep it at 16. I know I'm cutting a corner here, but it makes it easier to make my point. And then you can look up the same information for hydrogen. And you can say, look, hydrogen has an average atomic mass of about 1 AMU. And again, I'm cutting a corner because it's really a little bit more than 1, but close enough to 1 that we can just say 1. Because oxygen has an average mass of 16 AMU and hydrogen has an average mass of 1 AMU, you can basically say that the average oxygen atom is about 16 times heavier than the average hydrogen atom. And hopefully that makes sense just by comparing these two numbers. And if it helps to think about it visually, this is roughly your average oxygen atom. Oxygen has 8 protons, and there are the 8 red circles. And because your average oxygen atom has a mass of about 16 AMU, your average oxygen atom is also going to have 8 neutrons. There they are. So here's your typical oxygen atom, and let's compare it to your typical hydrogen atom. Hopefully you can see just visually that this oxygen atom over here on the left is going to be about 16 times heavier than this hydrogen atom over here on the right. Now, why am I pointing this out? For a couple of reasons. The first of which is that thinking about the atoms in this way, that certain atoms are heavier than other types of atoms, puts you in the right frame of mind for thinking about Unit 5. The second thing is that you can do this for any two elements. So you can look at the periodic table and you can compare the average mass of any two elements. You can look at helium and compare it to hydrogen, and you can basically say, look, your average helium atom is about 4 times heavier than your average hydrogen atom. Your average carbon atom has a mass of 12 atomic mass units. You can say that your typical carbon is about 3 times heavier than your typical helium atom. So you can just compare the atoms and figure out who's heavier, who's lighter, and how much heavier each one is compared to other ones. So that's another piece of information that I at least want you to have percolating through your mind as you go through Chapter 5. This is the last part of the review, and this deals with definitions that we went through in Units 1, 2, and 3. But basically, I just want to describe the difference between atoms and molecules, because this also comes up in Unit 5. Our definition of a molecule was 2 or more atoms that are attached to each other. If I just write the letter H, I am basically just talking about one hydrogen atom, and the emphasis here is on atom. One H all by itself is basically saying that this hydrogen is not attached to anything. So this is not a hydrogen molecule, it's a hydrogen atom. If I write H with a subscript of 2, this subscript basically means that there are 2 hydrogen atoms, but they are attached to each other. And so H2 here, this thing over here, is one hydrogen molecule. Another way of drawing H2 is to draw capital letter H, and then a solid line, and then another capital letter H. If you remember, the solid line means covalent bond, so this hydrogen is covalently attached to this other hydrogen over here, and even though separately this H on the right and this H on the left are hydrogen atoms, together when they are attached to each other, they make one single hydrogen molecule. And then again, in a similar way, if I wrote the letter H, and then a space, and then the letter H, and then another space and the letter O, I am basically describing 2 hydrogen atoms and 1 oxygen atom. And I am basically saying that these atoms are not attached to each other. They're moving around independent of each other. On the other hand, if I write H with a subscript of 2 and then the capital letter O, all connected to each other, like this, then I am describing one water molecule. So this is a representation of a single water molecule, and basically I'm saying that all of these atoms are attached to each other in some way. So I want you to really keep in mind the distinction between a molecule, which is going to have at least two atoms stuck to each other, possibly more, like I'm showing you here. I want you to make the distinction between a molecule and atoms. Individual atoms are not connected to anything else. They're just sort of floating around all by themselves. So that's the end of the review. We're going to pick up now with new material beginning the first half of Unit 5, Chapter 5.